we're going to talk about models of atoms today, and specifically the chemical formula, the ball and stick model, and the space filling model, and structural formulas. And so we want to represent atoms and molecules because often it's very advantageous to be able to picture these in our head. Now we know matter is anything that has mass and takes up space. We have different types of matter. We can classify it based on the size of the matter. Macroscopic matter, that means it can be seen with the naked eye. This would be like a grain of sand, a dog, a cat, a giraffe, whatever. Microscopic matter, though, has to be seen. It's small enough that we need microscopes to see it. These could be cells, bacteria, plankton. And then even smaller than microscopic matter is particulate matter, where it's even too small to be seen with the aid of microscopes. Now, sure, we can see some of the larger atoms with the scanning, tunneling electron microscopes, but that doesn't give us a good image of it. So particulate matter is very, very, very small matter on the atomic level or the molecular level. And scientists often want to visualize this. This is what we're concerned with, especially chemists are concerned with particulate matter and how things operate on that very tiny scale, what's combining with what. Now, the particulate matter we'll be dealing with is atoms, molecules, ions, and formulas units. And up to now, we've been talking about atoms and molecules. Ions are charged atoms. Some atoms can gain or lose electrons, and so we call them charged atoms. And you'll know it's an ion because you'll see the charge on there. It's either +1, +2, +3, or -1, -2, -3. Now, a formula unit is a molecule that's made of charged atoms. Technically, we're not supposed to call them molecules. We call them formula units. And that's because positive and a negative ions will attract and form a formula unit. However, in reality, molecules and formula units act very similarly in most cases. So when I say formula unit, just think of charged atoms that act like a molecule. Now here are the models that I expect you to know. The structural formula, back here, sorry. The structural formula, ball and stick model, and the space filling model. And so you have examples of these. And we'll look at these, and of course the chemical formula we'll start off with. Each of them have their own advantages and disadvantages. We use them for different reasons. Here I start with the chemical formula. No, it's just H2O, CO2 for carbon dioxide, CH4 for methane. We use these in chemical formulas. It's a lot easier it's a shorthand way of writing molecules. It tells us the elements that are in the molecule or formula unit, and also the subscripts tell us the number of each atoms of each element. The ball and stick model we sometimes want to use because it shows how the atoms are bonded together. The sticks represent the bonding electrons, okay, and the ball part is the nucleus and the non-bonding electrons, essentially. And so sometimes this can really help us understand the angles between the atoms, which can be very important, which leads to the shape of the molecule, and that can be very, very useful. And then a space filling model also indicates the shape of the atom and how things are bonded. But it's a little bit more realistic in that the electrons are in these regions of space, and when they bond the electrons, those orbitals overlap. And so this is probably a little more realistic. Okay, and that's all we have to do.